Welcome back to the YouTube channel on American Professor. We're going to be continuing our previous video on sets, set creation, and within this video, we're going to be discussing what can you do with sets. So let's take the same example from the last time, the set S, which has the values 0, 1, and 2, and print that. We can also run the help function on S to see what sort of methods it has. So last time we covered set creation from iterables and also from manual creation with the curly braces. And as above, you see how we can manually create sets. Now let's cover some of the main methods. You can add elements to set using add, you can clear sets, you can remove all elements, you can create shallow copies using copy to a variable. Let's discuss some of these more dynamic functions. So let's take two sets, S1 and S2. S1 goes from -1 to 3 in steps of 1, and set S2 goes from -1 to 1 in steps of 1. Let's print those out. Print out S2. You can notice they're unordered because every time you print them, you will verify that they're not ordered as we created them up here. So let's first do the difference of set S1 with S2. These are the elements that are in S1 but not in S2. That's what this notation means, S1 minus S2. If we want to throw away an element from a set, we can run the discard function. So let's throw away 3 from S1. So you can see 3 is no longer an element. We only have the elements -1, 0, 1, and 2. Let's find the intersection of the two sets between, that is, those elements that are both in S1 and S2. So we get -1, 0, 1, which is true, -1, 0, 1, -1, 0, 1, that's true. And disjoint checks to see if the two sets share no elements between each other. Here is false, obviously, because this is a non-empty set. We just check the intersection. And we can also run the isSubset function for S1 to check to see if one set is a subset of the other, which is obviously false here. And then we can also check to see if this set S1 contains another set S2, which is obviously false here as well. Some other rules on sets is that you cannot index into them like you can with numerical indexing for list or for tuples. And there's no concept of indexing even as we had for dictionaries, even though dictionaries use keys for indexing. See, type error. Set object does not support indexing. So the sets, you cannot index into them. So obviously you cannot change the elements after the set has been created. Set object does not support item assignments. But you can add an element to a set. So one other thing you could possibly do if you want to grow the set is add an element. Let's add 100 to our set. Print S1 now. You can see that the new element has been added. And that's it for this video. Hope you enjoyed it and learned some new things about container types in Python. Now we're done with the basic container types in Python. That is list, tuples, dictionaries, and now sets. With these, we can start to make very interesting programs, and pretty soon we'll be getting into conditional logic, so if statements, for loop, and iterations. And so we'll be even returning to these container types, as now we can loop over them and make more dynamic programs. That's it for this video. Please hit that like and subscribe button. Have a blessed day.